Good morning, friends. Today we are going to discuss the numerical on the base of compound microscope. In last we discussed about the compound microscope and we obtained the equation of magnification for compound microscope. So how we can calculate numerically the magnification and position of the object? So we can obtain the position of an image at particular position, that means at infinite distance and also at least the near distance, right? Okay, we are going to discuss in this numerical. Here the question is given like this way: a compound microscope consists of the convex lens with the focal length or the objective with focal length 2 centimeter. Focal length of object is given the 2 centimeter and eyepiece with focal length 6.25 centimeter, separated by the distance 15 centimeter. So distance between these two lenses is 15 centimeter. Now find the position of an object should be placed to obtain its image at first the least distance for distinct vision, that means the D is equal to 25 centimeter, and second is at infinite. That means, so how far from the object is placed to obtain the image of this object, first at distinct point and second is at infinite distance. Already we discussed in compound microscope. Here the two lenses, there is the objective, there is the eyepiece. We know that with help of eyepiece we can obtain the image is first at D distance and second is at infinite distance. Infinite distance. So we have to find out in both cases what is the position of an object must be placed from the objective. Clear this thing? Okay. For that purpose, how we calculate it? For that purpose, here the basic diagram of the compound microscope is this. So there is the objective. For understanding only, there is the eyepiece. There is the eyepiece. So here the object. So this distance is object distance for objective. So its image is formed at this point, near to the principal focus of the focal plane of eyepiece. That is the F. That is the F. And this distance is our V0. Is our V0. Now, for eyepiece, this distance is the object distance. The final image, here one image is formed. There is the ADS, BDS. There is the AB. There is our object. There is the image. And final image is formed at here, magnified image. There is the A double dash, B double dash. This distance is D or V for eyepiece. So here we have to calculate this numerical from first for eyepiece. We are using the lens equation. Here the V is known because we want to obtain first image at near point distance. That means the V is equal to 25. That is our image distance. Right? For this image distance, first we find out the U by using the lens equation. After obtaining the UE, now distance between these two lenses is given 15 centimeter. So 15 minus this UE, so that gives the V0. V0 no one. Again use the lens equation for objective. So we obtain the U0. We obtain the U0. So that is our requirement. Clear this? Okay. So for that purpose, whatever the data are given, there is only for information this figure. Now focal length of objective FO is given to 2 centimeter. Focal length of eyepiece FE is given as the 6.25 centimeter. Distance between two lens or the objective and eyepiece is equal to 15 centimeter. Is equal to 15 centimeter. And near point distance capital D is equal to 25 centimeter. So first for eyepiece, from lens formula, lens formula is minus 1 upon 2e plus 1 upon v is equal to 1 upon 8. Now, 4.8. 4.8. Yes, please. Image is formatted near point distance. For near point distance, near point, and lens equation for eyepiece minus 1 upon UE plus 1 upon V is equal to 1 upon FP. Take the UE this side, FP this side. Therefore, 1 upon UE is equal to 1 upon V minus 1 upon FP. Clear this? So that is from lens equation. Substitute the value. So 1 upon UE is equal to 1 upon V. V is our DE. Now, the D is our V, there is negative. Therefore, 1 upon minus 25. Minus. What is the focal length of eyepiece that is given? 1 upon 6.25. Here we are using this concept. V is equal to D is equal to minus 25 centimeter, because the same side we obtain. Therefore, 1 upon UE is equal to, here the LCM is 25. So minus 1 minus 4, therefore minus 5 upon 25, so it's equal to minus 1 upon 5. Therefore, UE is equal to minus 5 centimeter. There is the object distance for eyepiece. Okay. That means we obtain this distance. Now, distance between two lenses is given 15. 15 minus UE, that gives the image distance for objective. But distance between objective and eyepiece is equal to 15 centimeter. Therefore, image distance for objective is equal to 15 minus 5, that means the 10 centimeter. There is the 10 centimeter. Here 10 centimeter is falling. There is our VO. There is our VO. Now, for objective lens equation, so minus 1 upon U0 plus 1 upon V0 is equal to 1 upon F0. We require the U0. Therefore, taking this side is equal to 1 upon V0 minus 1 upon F0. 1 upon V0 minus 1 upon F0. Now listen, V0 we obtain, that is the 10 centimeter, F0 is 2 centimeter. Therefore, 1 by 10 minus 1 by 2. 1 by 10 minus 1 by 2. Therefore, simplifying this, we obtain the U0 is equal to minus 2.5 centimeter. That is the object distance of an object from the objective. Clear this? So, as we place the object at 2.5 centimeter distance from the objective, so it's a final image in compound microscope we obtain at near point. At near point. Now, the magnification of a compound microscope or the magnifying power. Now, magnifying power. That means the result of magnification, M is equal to M0 into M. That means the magnification of objective into magnification of eyepiece. Magnification of objective V0 upon U0 into here. The image formed by the eyepiece at near point distance. Therefore, in case of near point distance, the magnification of eyepiece is D upon F. 1 plus D upon F. Now, what's the value of V0? V0 is 10, U0 is 2.5. Therefore, 10 upon 2.5. Here 1 plus D. D is our 25 centimeter. And FE is 6.25. 6.25. And now 10 by 25, that is the 4. And the 1 plus 4, that is the 5. That is the 20. So magnification, in this case, the magnifying power of a compound microscope is 20 in that case. Now here, what are the values substituted of V0, U0, D, Fe? Here only we are interested to calculate the magnification. All values are considered positive, not with the sign convention. Here we only find out the magnitude of magnifying power or the magnitude of magnification. Clear this thing? Okay. So, quite lengthy numerical, but if you understand first what this numerical say that, for that is very easy. We have to apply the 2 times the length equation. And from last point we have to calculate in distance given, first find out the object distance for eyepiece. Now, this object distance, we know the total distance between 2 lenses. Subtract this distance from total distance, we obtain the image distance for objective. Again, use the length equation, we find out the DC. Now, second part of this question, if the image format at infinite for infinity, that means this VE is equal to infinite. VE is equal to infinite. For eyepiece, we are using the length equation. So minus 1 upon UE plus 1 upon V is equal to 1 upon F. Therefore, minus 1 upon UE plus 1 upon infinite is equal to 1 upon F. 1 upon infinite 0 minus 1 upon UE plus 0 is equal to 1 upon Fe. 1 upon F. Therefore, UE is equal to minus Fe. UE is equal to minus Fe. Now, Fe, focal length of the eyepiece is given, there is the 6.25. There is the 6.25 centimeter. So, minus 6.25 centimeter, there is the image distance for the eyepiece. UE is known as 6.25. But distance between objective and eyepiece is 15 centimeter. Therefore, the image distance for objective is V0 is equal to 15 minus 6.25 is equal to 8.75 centimeter. Here is the 8.75 centimeter. Now, for objective, lens equation minus 1 upon U0 plus 1 upon V0 is equal to 1 upon F0. So here we substitute the value. So from this equation, 1 upon U0 is equal to 1 upon V0 minus 1 upon F0. As we substitute the value, so we obtain the object distance is minus 2.59 centimeter. 59 centimeter. And magnifying power M is equal to M0 into ME. Now listen. Here we are discussing the second case for infinite. If the image is formatted in infinite distance in simple microscope, the magnification is only D upon FE. Therefore, V0 upon U0, there is the magnification of objective into D upon FE. D upon FE. So now V0 is 8.75. U0 is minus 2.59, that means the 2.59. Yeah, D 25, FE 6.25. 6.25. Therefore, we obtain the magnification is 13.5. Simplify yourself. So now what's happened? Here, first case, if the image is formatted at near point distance, at that time the magnification is 20. Now, if the image is formatted at infinite distance, magnification is reduced, there is a 13.5 centimeter. So in second case, the image formatted by the objective must be on the principal focus of the eyepiece. So as a result, the final image formatted by the eyepiece is at infinite distance. While in first case, here the final image formatted by the compound microscope, that means the eyepiece is near point distance. Therefore, the image formatted by the objective is not on the principal focus of the eyepiece, but smaller value of this focal length of a eyepiece. There is, so there is a quite lengthy numerical, but the both parts are same, only the numerical value are changed. Clear? Okay, now next numerical is 9.12. In 9.12, there is also similar to the earlier 9.11. But here, what is the difference between them? So here the focal length of objective eyepiece both are given, and here the object distance from objective is also given. We have to find out the distance between the objective and eyepiece. Objective and eyepiece. Now the question is that a man with near point distance 25 centimeter using a compound microscope with objective of focal length 8 millimeter. That means the focal length of objective F0, that is the 8 millimeter, that means the 0.8 centimeter, and eyepiece with focal length 2.5 centimeter. Focal length of eyepiece FE is equal to 2.5 centimeter. Now the object is placed at 9 millimeter from the objective. That means the object distance for objective, that is U is equal to 9 mm is equal to 0.9 centimeter. Now find the distance between objective and eyepiece. Objective and eyepiece, we have to find out what is the separation between them. So first thing, again for our understanding only, I draw the position of objective, eyepiece, and also the object in image. So there is the objective, there is the eyepiece. We require the distance between these two lenses. We have to find out. Now the object is placed at this distance. There is given there is U0. Okay. The image formed by the object is formed at principal or the focal plane of eyepiece. That means here. So this distance is our FE. This distance is our FE. This distance is B1. That is our F4. Our F4. Now this distance is our image distance for the objective, and that is our object distance for eyepiece. That is the U. Okay. Now the addition of V0 plus UE, that is the separation between the two lenses. For eyepiece, the final image is formed at distance B. At distance D, D is given the 25 centimeter. 25 centimeter. Because in question is given a person with normal distance. Normal distance is given the 25 centimeter using a compound microscope. With the objective with focal length 8 millimeter, that means the 0.8 centimeter, and eyepiece with focal length 2.5 centimeter. An object is placed at 9 millimeter from the objective lens. Find the distance between the objective and eyepiece. So how we calculate it? For that purpose, we get the idea from the block diagram of compound microscope. There is objective, there is the eyepiece. The distance between the objective and eyepiece is equal to the image distance for objective and object distance for eyepiece. The addition of V0 plus UE gives this distance. Now U0 no one, U0 no one, F4, FE no one. So first we are using the lens equation. F4, F1, U are known, so we find out the V. For eyepiece, the final image is formed at near point. That means there is the V. V no one, FE no one. We can calculate the V. We can calculate the UE. Therefore, V0 plus UE, that gives our answer. Distance between these two. Okay. Now, we first calculate for objective. For objective, FO is equal to 0.8 centimeter, 0.8 centimeter, and UO, that means the object distance, UO is equal to minus 0.9 centimeter. Therefore, from lens formula, for objective, minus 1 upon u0 plus 1 upon v0 is equal to 1 upon f0. We are interested to find out this. 1 upon v0 is equal to 1 upon f0 plus 1 upon u0. 1 upon f0, 0.8 plus 1 upon u0, 0.9. Therefore, 1 upon minus 0.9. Because the u0 is negative, minus 0.9 centimeter. Therefore, 0.9 minus 0.8 upon 0.72. Simplification. Therefore, V0 is equal to 7.2 centimeter. 7.2 centimeter. Now, for eyepiece we are using for eyepiece. Now, VE is given. There is the minus 25 centimeter. FE. FE is given 2.5 centimeter. We have to find out the UE. So from lens formula, so minus 1 upon UE plus 1 upon V is equal to 1 upon F. Therefore, 1 upon UE is equal to 1 upon V minus 1 upon F. 1 upon V minus 1 upon FE. So here V minus, therefore 1 upon minus 25 minus 1 upon FE 2.5. So here we can obtain 1 upon UE is equal to minus 1 minus 10 upon 25 minus 10 minus 1 minus 10 upon 25. 25 is the LCM. Therefore, minus 11 by 25 1 upon UE. Therefore, UE is equal to 25 by 11 minus, so is equal to minus 2.25 centimeter. Then UE is equal to 2.27 centimeter. Therefore, the distance between objective and eyepiece is equal to V0 plus UE. What is the V0? 7.2 plus this 2.27. Therefore, 9.47 centimeter is the separation between the two lens. Clear this? So that is the same numerical of 9.11. In 9.11, here the separation between the two lenses are given. We have to find out the magnification power and also the position of an object. Here, position of an object given, we have to find out the separation between the two lenses. Now, the last portion of this numerical is find out the magnification of the magnifying power of this compound microscope. Therefore, magnification M is equal to MO into ME. That means the magnification by the objective into magnification by the eyepiece. Magnification by objective is V0 upon U0. Now here, the image formed by the eyepiece is at near point distance. Therefore, the magnification is 1 plus D upon F. 1 plus D upon F. Here we substitute the value. Now, what is the V0? 7.2. 7.2. Now, what is the U0? U0 is 0.9. Here, 1 plus D, 25. FP, 6 point, FP is 2.5. 2.5. So here there is the 8. Here 1 plus 10. That means the 8 into 11. That means the 88 is the magnifying power or the magnification of a compound microscope. It is a compound microscope. So here, so the both numerical are same earlier and this.